Hello my dear student, how are you? I hope all of you are well and doing good. So welcome in this second lecture of Abhyas batch. So today we are going to discuss production planning control and linear programming. Right, some questions regarding to this topic. So without delaying any, I'm going to start the questions. So this is a question. Please try to give the answer. Routing is a production planning control refers to the routing. Yes, very good morning to all. Very good morning to all. Yeah, please tell me, routing in production planning and control refers to what? Yes, what it refers? That is D. Yes, I'm not able to see your answer. Yes, it's a option D. Very good. Sequencing, basically routing is what? Routing basically sequence of operation to be performed. We have to arrange some sequence. We have to arrange some sequence of the operation so that the operation can run very smoothly, right? Run very smoothly. So this is the right answer. Option D is the correct answer. Now let's move. The following activity. Yes, please. Next question. The following activities are to be performed in a particular sequence for routing a product. Okay. So the correct sequence of this activity is, what is the correct sequence? Tell me. Analysis of the product and breaking it down into the component. Second, detection of the lot size, determination of operation and processing time requirement, taking makes or buy decision. Yes, so which one is the right answer? Tell me. Which one is the right answer? It is clear that whatever you do, you have to analysis of the product and break it down into components. Then you will do a further thing now. So one is my basic step. My dear, one is my basic step, right? One is my starting step. If one is my starting step, then your option B is not your answer. Even option C is not your answer. Now only two options left. That is option A and option D. Okay. Now we have to decide whether 2 will come after the 1 or 4 will come after the 1. So 2 is what? Determination of the lot size. Okay. My dear, 2 is what? Determination of the lot size will be depend when you are going to take a decision on what? For a buy or taking makes or buy decision. If you have taken for manufacturing decision, if you have taken for buying decision, then you are going to divide into the lot na. Then you are going to divide into the lot size na. Before taking anything, right? Before taking order, okay, or before decided whether which you want to buy, which thing you want to buy, how can you determine a lot size? First of all, you have to take a decision, right? First of all, you have to take the decision. Am I right or clear? Sir, whether our comment are visible or not? Yeah, it is visible, but my screen is little bit farther away from me. That's why it is not visible, but don't worry. I will come to the screen and I will see your comment. You just focus on the question. Yes, D is your right answer. So after 1, 4 will come. So D is your right answer, right? D is your right answer. Very good. Next question, please. Consider next question. Consider the following statement. Scheduling is what? Is a journal timetable for manufacturing? Is the time phase of loading? Is loading all the work piece, all the work in process on machines according to their capacity. My dear, fourth will be not the answer, because fourth is not given, and even in the option it is not given. Suppose that if I write 1, 2 and 4, right? If I write that 1, 2 and 4, 1, 3 and 4, then tell me which option you will select. Which option you will select? Scheduling is what? Yes? Yeah, please participate. Scheduling is what? So scheduling basically, in schedule, basically you are going to arrange the work now according. So scheduling is what? Is the general timetable. My dear, scheduling is a general timetable, yaar. Okay, according to SPT, RKJ and Manoj Kumar, according to SPT, CRR, critical rule ratio method, shortest processing time, they are what? They are give the general timetable, na? They are give the general timetable, yes or no? So first is the right. First is right. So is a general timetable of manufacturing. So first, either your option D, B or A. So second is not my answer. C is not my answer first of all. First is the correct one. So the option is A, B and D. Now I have to check all the options. Now I have to check all the statement. Now is the scheduling is what? Is the time phase of loading? Yes. Suppose that two machines are there. When one workpiece is going to load on first machine, and when the processing will be done on the first machine, then it will unload and it will load onto the second machine. Meanwhile, what happened? Another workpiece, another job will load on the first machine. So basically it will give is the time phase of the loading. Yes or no? It will give the time phase of the loading. So second is also correct. Here second is there and here second is there. So it means D is not my answer. So I have to select from A and B. Now third is loading all the work in process on. Yes, when you load some workpiece on the machine, then it shows that workpiece is going on a processing. There will be a processing on the workpiece on a particular machine. So here the third is also right, but in this third option is not there. Let me check the fourth. Machine according to their capacity. My dear, machine according to the capacity, if it is making any doubt, okay, what I'm going to do, I'm going to remove this statement. Okay, maybe it may create any doubt. I will remove this thing. I will remove this thing. Now here 1, 2, 3. Now here 1, 2, 3 is the correct option. Now here 1, 2, 3 is what? Here 1, 2, 3 is what? The correct option, that is your option A. Am I clear? That is your option A, my dear. That is your option A. Now let's move. Next question. Next question. Right. Consider the following statement. Consider the following statement. Yes, consider the following statement. Preparation of master production schedule is an iterative process. Yes or no? Yes or no? Preparation of master production. Preparation of master production. Preparation of master production. Preparation of master production schedule is an iterative process. Schedule chart are made with respect to the job, while load charts are made with respect to machine. MRP, material requirement planning. MRP is what? Material requirement planning is done before master production schedule. What do you say? MRP will done before. What do you say? MRP will done before the master production. You say MRP. You say MRP. My dear RJK, you are saying option D. It means MRP is done before the master production schedule. MRP is done before the master production schedule. You say D. What do you mean to say? Material requirement planning is done before the master production schedule. My dear RJK, my dear student, first of all, master production schedule you are going to make. According to the master production schedule, you will get how many products are in the inventory, how many products we have ordered, how many products right now required. According to that, MRP, material requirement planning, will be done. Am I clear? Material requirement planning will be done on the basis of inventory record. material planning will be done on the basis of the product, the raw material which you have ordered. Okay, MRP planning will be done on the basis of the design of the product, the design of the product. And when you will get the design of the product, when you have already prepared a master production, a master production schedule. Am I right or wrong? Tell me, am I right or wrong? I gave the explanation. Now you tell me, am I right now? So how can you prepare MRP before master production schedule? Here the statement 3 is completely wrong, right? So statement 3 is completely wrong, means 3 not 3 not 3 not. So only option is what? 1 and 2. Automatically 1 and 2 is going to be what? Selected. My dear, first of all, try to understand all the statement and eliminate. Sometime you can do a question by two way. Entertainment show, good morning. Okay. My dear, you can answer the question by two way. First, whether you know, first that you know the answer exactly. If you don't know the answer exactly, then eliminate the option. Then eliminate the option, right? This is the two way by which you can attempt a question, right? Okay. Which of the following factors are to be considered for production schedule? Which of the following factors are to be considered for production schedule? Yes, tell me. Yes, tell me. Tell me. Which of the following factors are to be considered for production schedule? Sales forecast, component design, route sheet, time standard. Yes. 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 No, my dear. Try to understand. Production schedule. Production schedule. Now, this schedule basically based how many demand you are expecting. How many demand you are expecting. You are expecting, right? How many demand you are expecting. According to that, you can do the production na? Yes or no? First of all, tell me. How many demand you are expecting? According to that, you can plan the manufacturing. You can plan the manufacturing things. You can arrange the manpower. You can arrange the machine. You can arrange the raw material, and it will be done on the basis of forecasting or not. Sales forecasting, forecasting or not. So here 1 is your compulsory component. So 1 is your compulsory component. So D is going to be what? Cancel. Right? D is going to be what? Cancel. Okay, Suraj Pandit. D is going to be what? Cancel. Now option A, C, B is remaining. Now let's see one by one. Component design. Yes, according to the component design, you schedule the thing. Because according to the component design, we get an idea that how much time that product is going to consume on a machine, how much time is going to take on a particular machine. According to that, we can apply SPT, shortest processing time rule, earliest due date rule, critical ratio rule, right? So component design is also an important factor. So 1 and 2, 1 and 2. Oh my God. So C. My dear, C is not your answer, because 2 also required. Component design is also required. So here C is going to what? Cancel. Here C is going to what? Cancel. Are you getting the thing? Are you getting that thing? My dear, route sheet. Route sheet. Route sheet, or you can say time standards. Route sheet, or you can say time standard. Now, they are very much closer. They are very much closer. They are very much closer. Which of the following factors are to be considered for production scheduling? They are very much closer. Route sheet and timetable. Route sheet and timetable. My dear, timetable, route sheet or time standard. My dear, time standards will become on the basis of basically route time standard will give all the information. Time standard will give all the information. Suraj Pandit, please listen me carefully. Time standard will give all the information when your product is going to be load and when the product is going to be unload, when there is a delay, okay, when there is a delay, how much a product is going to be wait, okay, to load on the machine, what is the ideal time of machine first, what is the ideal time of machine second, what is the ideal time of machine, okay, and third, and so on. Even how much product has to wait. So overall time standard will provide you the scheduling information, right? Route sheet is a part of time standard, my dear. Route sheet is a part of time standard, right? Route sheet is a part of what? Time standard. So they are very close. They are very close. So you have to select the fourth one. So that's why your option become what? B. So that's why your option become what? B. Am I clear? Okay. Now let's move to the next question. Don't worry, numerical questions are also there. Numerical questions are also there. Very good numerical question I have, right? Very good numerical questions I have. Don't worry. Don't worry. Which one of the following chart gives simultaneous information about the progress of work and machine loading? Work and machine loading. This is a very easy question. Yes. RJK Gantt chart will give Gantt chart will give processing time. Processing time of job. Processing time. RJK, listen me carefully. Listen me carefully. Gantt chart. Gantt chart. If you have drawn the Gantt chart in production planning control, then what you plot? Recall in your mind what you plot. You plot that a machine, basically Gantt chart is what? Let me explain you. This is the, suppose that you are making a Gantt chart, right? You are making a Gantt chart. Okay, now you have divided 0, 2, 4, 6, 8, 10 and this is 12. This is machine A. Okay, machine A. This is machine A. This is machine B. Now, suppose that, please try to understand, I am explaining. Here, the Gantt chart will tell you what? When you load a job on machine A at 0, suppose that machine A on 0, okay. Now from 0 to 6, from 0 to 6, a processing will be happen on a particular job, that is what? Let's say J1. Meanwhile, machine B is waiting. Okay, meanwhile machine B is waiting. So this is a waiting time, processing time and waiting time. My dear student, Gantt chart will only show you the processing and ideal time of the machine, yes or no? Gantt chart will only show you the processing time and your ideal time of the machine, yes or no? Tell me. Yes na? Then how can you select a Gantt chart? He clearly asking you that which chart will give the information of work and machine loading. Work and machine loading. Simple. Machine load chart. Machine load chart. Machine load chart. Am I clear? Machine load chart. At which time you unloaded and at which time you unload it. So basically a machine load chart will give you the information. It's a very important question. Very important question. Very important question, my dear. Very, very important question. It's a 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 very, very important question. It covers all the concept of PPC. That question covers all the concept, all the theoretical concept, all the theory concept of PPC, that is production planning control. This question will cover all the concept of PPC. Now let me explain this question. First of all, this question came from PPC, production planning control. As you know, a manufacturing unit perform variety of production operation and produce a various range of product, and each activity has to be planned and direction given specifically for the performance of individual operation. Here PPC comes. PPC acts as the nervous center for planning the activity and sending the continuous stream of direction to all the manufacturing department, my dear. So here PPC has some functions, has some activity. What are they? First is routing. What are the routing? Routing consists of deciding the path the item would takes in it transformation from raw material to final product. So it involves a creation of route sheet. It involves the creation of route sheet which contain many information. So first is your routing. Where is the routing? So routing, right? Am I clear? So it has some function, routing. So try to understand all the thing. What he say? Routing is there. Routing is there. Yes. So routing. Okay. Routing. So second thing is that loading. A loading is also second function. What do a loading basically do? The work of transformation of the raw material. The work of transformation of the raw material has to be covered into workload on an individual machine. Workload on individual machine. This process is known as what? Loading. Then third term, that is balancing. It is a process of ensuring that the individual workload on each of the machine is more or less the same, right? Next is your scheduling. It answers the question that when a work will be done, within what time it will be completed. Component design. Okay, component design, right? Component design. Also the next function is the dispatch. What is the dispatch? Dispatch, it deals with the smooth introduction of work. Dispatch, it deals with the smooth introduction of work on the shop floor. It includes release of work order, release of tool drawing, etc. on the shop floor in their required sequence. So authorizing a production work order to be launched here. It should be noted that. And the next is follow up. This function of PPC deals with the control or the feedback part to ensure a smooth running of all the previous operation. Now according to that, give me the answer. Now you understood now. I have clear all the terminology. Okay, which is given in the thing. Planning is what? Planning is a necessary thing, my dear. Planning is a necessary thing. So one must be the first thing. One must be the first thing. Yes or no? One must be the first thing. So 1 comes first. Then after what comes? Routing. Then after which come? Routing. 1, 5. My dear, 1, 5. After routing, what it comes? After routing, what it come? Scheduling. Right. So scheduling is required. 3 is here. 3 is here. After scheduling, what it required? After scheduling, what it required? Loading, or fourth is what? Dispatching. No. Loading is required. Loading is required, my dear. Arey, my dear, you say scheduling. My dear, scheduling we have done. My dear, after scheduling, what you say? You say what? Loading, dispatching. My dear, you do dispatch when the processing will be done, and processing will be done when there will be what? There will be loading on a machine. So loading is required. After loading, you ensure that after loading, you ensure that processing will be gone on, and after processing, the workpiece will dispatch from one machine to another machine, or one department to another department. So then dispatch will come. Then the dispatching thing, okay, the transferring thing is going to the proper location or not. For that you have to do a follow up. So C is the correct answer. C is the correct answer. Am I clear? Yes or no? Am I clear? My dear student, tell me, am I clear or not? Is that point is clear? Okay, good. Now, dispatching function of production planning and control refers to. I discussed the dispatching function. I have discussed the dispatching function in the previous question. Remember, in a previous question, I have discussed the dispatching function in the previous question. Yes. So what is the dispatching? My dear, movement of in process material from one shop to it is an authorized movement. Without any authorization you cannot move. I told you authorization word. In dispatching, I mention a word authorization. So authorizing a product work order to be launched. Right. Authorizing a product work order to be launched. Right. Next question. In a low volume production, dispatch function is not concerned with the issuing of which one of the following? Low volume. In a low volume production, the dispatching function is not a concern with the issuing of. Actually, first of all, try to understand the dispatch. My dear, first of all, try to understand the dispatch. Suppose this is one shop floor. This is another shop floor. Okay, try to understand. Right? Try to understand. This is another shop floor. 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 So many. In a manufacturing unit, try to understand. In a manufacturing unit, there are various. Try to understand. There are what? There are various shop floor. Yes or no? Suppose that this is a shop floor number 1. Suppose that this is 2, this is 3, this is 4, this is 5, this is 6, 7, 8, 9, 10, 11 and 12. And you know, in a manufacturing, okay, in a factory, there are many shop floors. And suppose that after processing, a material will transfer from 1 to 2. Okay. Then this dispatching will be done by a authorization, so that the shop floor on the person who is on the first shop floor should know, okay, I have dispatched, okay, from my order. If any fault will become, then I am responsible. Okay, then this will go to this shop floor, and it may be chance this will go to this shop floor, and it will go to this shop floor, and this will go into the this shop floor, 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 again this will go into the this shop floor, again this will go into the this shop floor, again this will go into the this shop floor. You can see that a particular product is moving in so many shop floor. If you are giving an authorized ticket from if you are giving an authorized ticket, okay, to the movement of any order, any product from one shop floor to second shop floor, then you are making a record in your register. Basically, you are making a record in your register. You are giving authorization, right? So if any fault come in any route, then you can easily find out in the large network. So that you can easily find out in the large network that by which the fault comes in the system. Okay, by which shop floor or by which person's shop floor the fault comes in a picture, fault comes. Okay, so you can get that error, you can find out that error if you maintain the record, and that record is a dispatching order, authorized order. Am I clear? Am I clear? Am I clear? Yes or no? Tell me. Am I clear? Arey yaar, tell me na. Okay. Now, suppose that if there is a less shop floor, only one, 2 and 3. Suppose that there is a low volume production. In low volume production, only less shop floor is there. This person know him and this person know him. Okay, these 2 or 3 shop floor know to each other. We know and you know that either the product will move from 1 to 3 or 3 to 1 or 2 to 1. So here less number of shop floor means less production, low volume production. Yes or no? Low volume production. Okay, so in a low volume production, why we waste our time? My dear, listen me carefully. In a low volume production, why we waste our time to maintain the dispatching thing? Tell me. To maintain a dispatching thing? Yes or no? Tell me, to maintain the dispatching thing. Yes. So requisition of material, part and component. Requisition means what? Against the thing is same. Requisition, that you are requesting, you are giving some authorization of material to transfer from one location to another. This is not required. Right? This is not required. So my dear, requisition of raw material means you are requesting to transfer a raw material from one place to another place. Right? It is not required because already we have a low volume production. So why we waste our time? Okay, in between the 3 shop floor or 2 shop floor, here number of shop floor are less. So requisition of low material parts and components is the correct answer. Next question is your numerical. So it's my request to all of you. Please note down this table in your copy. Then we will do a solution. Right? Then we will do a solution. Am I clear? So before solving this question, please note down this table only. Not a question. Only this table. Sir, फिर वर्क टिकट क्या होगा? बेटा वर्क टिकट का अब यहाँ जरूरत नहीं है. वर्क टिकट बेसिकली वही होगा, रिक्वेस्टिंग. वर्क टिकट हर चीज के लिए, चाहे मैं आपको ऑर्डर सेंड करूं कि भाई मेरे को ऑर्डर आया है, शॉप फ्लोर पे ऑर्डर आया है कि ये काम करना है, उस ऑर्डर की जरूरत नहीं रही है क्योंकि वहां पे नंबर ऑफ लोग क्या है? कम है बेटा, है ना? नंबर ऑफ लोग कम है, एक दूसरे को सब जानते हैं, तो वहां पे फिर आपको ऑर्डर, वहां पे आपको रजिस्टर मेंटेन करने का जरूरत नहीं है, वहां पे आपको ऑथराइजेशन टिकट देने का जरूरत नहीं. पता है मैं इसको जानता हूं, वो उसको जानता है, तो वी आर नॉट गोइंग टू वेस्ट अवर टाइम इन लो वॉल्यूम प्रोडक्शन. Work ticket, that is same, that is the requisition of raw material from one shop floor to another shop floor. Work ticket is the same. You are giving order to for a manufacturing, right? Harsh Chauhan. Now, please note down this table. Then I will start the solution of this. Please note down this table. Please note down this table. Please note down. Please note down. And then let me know if you note. Let me know when you note when you have completed. Have you noted? Have you noted? My dear, have you noted or not? Have you noted or not? Have you noted? Have you noted? Okay, so shall we start? Okay, now let's start this. Now, here we have to do this question. What is the question basically? For the set of jobs, obtain a sequence applying SPT. What is SPT? Shortest processing time. What is SPT? Shortest processing time. Processing time, right? Shortest processing time. This is the SPT. So SPT rule you have to apply and arrange the job, right? Right. Calculate the make spend time. You have to calculate the make spend time. You have to calculate the job flow time. You have to calculate the average flow time per job. You have to calculate the average tardiness per job. You have to calculate average number of tardiness in job. So all the questions are there. Now all the things are there in the question, right? All the things. Now let's start. According to SPT, SPT is what? A job which has a shortest processing time. A job which has a shortest processing time, arrange first. Arrange first. Now, which job has a shortest processing time? Among them, E. So E will go, okay, E will go first for the processing, right? E will go first for the processing. Cut it down, right? Cut it down. Now, C. Again, after E, which job is there? C. That is 8. After E, I will use a different color. Yes, after E, your C will go. So cut it down, C. Now, after C, which will go? A, right? A will go. Cut it down. After A, which will go? B. Cut it down. After B, which will go? D. So sequence is what? Sequence is E, C, A, B, D. Am I clear? Sequence is what? Sequence is E, C, A, B, D. Okay. Now sequence that. Okay, sorry. Sequence that. So I am going to make a sequence, my dear. Right? I am going to make a sequence. Please see. Please see here. This is a table which I am going to draw, right? And this is a job, right? Job. Here you can see. This is a job. Job. And what are they? E. How many jobs are there? 1, 2, 3, 4, 5. 5. 1, 2, 3, 4 and 5, right? 4 and 5. Now, the sequence is ECABD. E, C, B, A, D. Let me check. E, C, A, B, D. Right? E, C, A, B, D. Now, you have to write down the flow time. Flow time. Right? You have to write the flow time. You have to write the due date. Due date also. Then you have to write down what? Tardiness. Tardiness. Right, tardiness. So, flow time and due date and tardiness. Now, what is the processing time of E? That is 6. So, write down 6. What is the processing time? What is the processing time of C? Remember, what is the processing time of C? C is what? 8. So, flow time is what? 8 plus 6. That is 14. Now, processing time of B is what? Sorry. Yeah, B is 16. So, flow time is what? 16 plus 14. That is 26. Again, processing time of A is what? Processing time of A, that is 12. Right? That is 12. So, here 12 plus 26, it will become what? 42. Right? It will become 42. Processing time of D. Processing time of D, that is 20. So, 20 plus 42, that is 62. Am I clear? Now, write down the due date also. Due date are what? These are the due date. According to that, write down the due date. Due date of E is 31. Due date of E is 31. Due date of C is what? Due date of C is 28. 28. Due date of B is what? Due date of B is what? 37. So here 37. Due date of A. A is what? That is 52. It is what? 52. Due date of which? Due date of D. D is what? Due date of D is 57. 57. Am I clear? Now here tardiness. Tardiness means what? Basically 62 is what? 62 is a flow, make spend time. Right? 62 is what? Make spend time. Now tardiness. Now this job is completed before the due date. So tardiness is what? 0. This job is completed before the due date. So tardiness is what? 0. Also job C is completed before due date. So tardiness is what? 0. Also due date, job B is completed before due date. So tardiness is what? 0. Also here, but job A also job A is also completed. 37. I think I have written wrong. I have written wrong. 31, 28, 28 and due date of, let me see. Due date, have I written the right due date? I think due date of E, that is 31. Due date of C, due date of C, that is 28. And due date of A, that is 52. Due date of A, oh ho, ECBD. I did the ECA. Here it come EC, A, B and D. EC. Yes. ECABD, right? It was a ECABD. Yeah. So here it come 20. Here it come what? 26. I add the processing time. And what is the processing time of B? B is 16. So 26 plus 16 is what? 42. And processing time of D is what? 20. So it comes 62. Now due date of E. Due date of E, see your table. Due date of E is what? 31. Due date of C is what? That is 28. Right? That is 28. Due date of A is what? 52. Okay, 52. Due date of B is what? 37. Right? Due date of your D is what? 57. Now it is right. Now here, my dear student, B is going to be late. B is going to be what? Late. By how much? 42 minus 37. That is 5. That is 5. D is also going to be late because it takes more than due date time. How much? 5. So how many jobs are going to be delayed? Number of jobs which are going to be delayed? 2. Find out the total job flow time. Find out the total job flow time. Now total job flow time is 6 plus 14 plus 26 plus 42 plus 62. It will become 150. Yes or no? It will become 150. Now make spend time. Here my dear, make spend time. Make spend time equal to what? Make spend time equal to your 62. Last job flow time. Last job flow time will become what? Make spend time. Now you have to find average. You have to find average flow time per job. Average flow time. Average flow time per job. How can you find average flow time per job? That is total job flow time. Total job flow time. Total job flow time divide by number of job. Number of job, right, equal to what? 150 divided by 5. 150 divided by 5, so it will become how much? 30. Now you have to find out what? Average tardiness per job. Average tardiness of job. Average tardiness of job. How many tardiness? How much tardiness? 0 plus 0 plus 0 plus 5 plus 5. It will be 10. Divided by number of job are what? 5. So 2 unit per job is a tardiness. Number of tardiness of a job. Number of tardiness of a job. Number of tardiness. 2 jobs. 2 jobs. Right? I hope the thing is clear. Right? I hope the thing is clear. Now let's move to the next question. My dear, first of all, please note down this table. First of all, note down this table, please. First of all, note down this table, please. First of all, note down this table, please. First of all, note down this table, please, and make the sequence. First of all, note down the table and make the sequence, please. First of all, note down the table and make the sequence. First of all, note down the table and make the sequence, please. First of all, note down the table and make the sequence. First of all, note down the table and make the sequence. Yes, 2, 4, 3, 5, 1. Yes. Now, I am going to explain. Have you noted the table? Have you noted the table? Have you noted the table? Yes, okay. Now, actually this is what? 2 jobs and machine problem. 2 jobs and machine problem. So in 2 jobs and machine problem, we have to apply Johnson algorithm. What Johnson says? Johnson says make a column, make a row, right? Make a row and divide that row into number of what? Divide that row into number of C. Okay, I am going to write. And this is a thing that any job, okay, processing for any job, it will load on machine 1 and then it will go to the machine 2. Write down in the front machine 1 and write down at the end machine 2. Now select the job which has the lowest processing time. Okay. Select the job which has the lowest processing time, my dear. So here you have seen 1 is the lowest processing time of J2 on M1. Okay, J2 on M1. So arrange that J2 near M1. So this is what? J2. Now remove this from the algorithm. Again select the smallest processing time, that is J1, on which M2. So arrange that J1 near what? M2. Now remove this. Select the smallest processing time again, that is what? 3. J4 M1. Okay, so arrange the J4 near M1. So this is what? J4. Okay, near M1 is this place. Now remove this. Select the near smallest processing time, that is what? 4 of job J5 on M2. So select J5 here, right? J5 here. Okay, J5 here. Okay, so this is going to be what? Cancel, and one job is still remaining, that is J3. It will become here J3. So this is what? Sequence 2 4 3 5 1. Are you getting 2 4 3 5 1? Yes, if you are getting 2 4 3 5 1, then your answer is correct. Then your answer is what? Then your answer is perfectly correct. Shall we move? Yes. Yes, shall we move to the next question? 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 Okay. Find the make spend time, ideal time for machine A and B. First of all, note down this table. First of all, note down this table. First of all, note down this table. First of all, note down this table, my dear. Note down this table. Please note down this table. Have you noted? Have you noted? Have you noted? Yes? Okay. Now, first of all, we have to arrange this. Right? We have to arrange this. So, make it arrangement. Make arrangement. Right here, machine A, and at the end write machine B. Now, find out the minimum processing time. Find out the minimum processing time. So, which has a minimum processing time? That is 1 of job 6. Let's say it is J. It is J. J3, J2 and J1. Right? This is J1, J2. Okay. Now, minimum processing time is 1 on B. So, arrange J6 on nearby machine B. Now, remove this row. Select the minimum processing time, that is 2 of J3 on machine A. So, J3 will come. Remove this. Select the minimum processing time, that is 3 of J1 on machine B. Arrange J1 near machine B. Remove that row. Okay, remove that row. Now again select the minimum processing time. Oh my dear, my dear, 4 and 4, they are equal. What to do? What to do? My dear, here 4, 4. 2 processing time are equal on different machine. What to do? 2 processing time are equal of different job on different machine. What to do? The rule says that when there is a processing time, that is J2 on machine A equal to processing time of J5 on machine, this is A machine, right? Please listen me carefully. Here I am writing what? Here I am writing the thing. This is what, my dear, this is what, please try to understand. On machine A, right, processing time of what? J2 equal to on machine B, processing time of what? J5 is what? Same. So in that case, you have to take both the job, that is J2 and J5, and arrange the job on their respective machine on which they are getting the time. So J2 are getting on machine A, so arrange J2 here and arrange J5 here, arrange J5 here. So this will going to be what? This will going to be cancel. This is going to be what? Cancel. Only one job is remaining, that is J4. That is J4. It's over. So 3, 2, 4, 5, 1, 6. Are you getting? 3, 2, 4, 5, 1, 6. Yes, you are getting. So this is the thing. Now we have to time the make spend. Now we have to find the make spend time. Now I'm going to remove this, right? Now I am going to remove this. I am going to remove this, right? I am going to remove this. Okay. Now my dear, here 3, 2, 4, 5, 1, 6, the sequence. Now here 3, 2, 4, 5, 1, 6 is the sequence. Okay. Now here we have to make a table, right? We have to make a table, right? Now I am going to make a table. Please try to understand. Please try to listen. Okay. Very carefully. Okay. In a single table, you will get all the answer. Job, you will get all the answer that are what? That are your jobs, machine A and machine B, and here one more column will become this, and this is your job. Okay, so here jobs, right? Write down here machine A, and write down there machine B. Write down there machine B. Right, write down there machine B. Now divide this. Again, there will be what? On machine A, there will be in or there will be out. There will be in, there will be what? Out. Right, there will be in and there will be out. Now, sequence all the, how many jobs? 6. So 6, right? So here 6. So here 6. Oh my God, what is happening? One, two, three, 4, 5, 6. Now see, listen. J3, J2, J4, J5, right, J1 and J6. Now, when the job, see your table and give me the answer. J3 will load on machine A at 0. J3 has how much a processing time? 2. So it will out on 2. Now J3 will load on machine at 2, and J3 has a processing time of what? 6 on machine B. So it will be out at 8. Is that clear? Okay, J3 has a processing time on machine B is what? J3 has a machining time. Let me write down. This is what? This is the J. Okay, this is what? J. Processing time 6, right? Again, now J2 will load at which time? At 2, right? Now J2 has a processing time 4 on machine A. So 4 plus 2, that is what? 6. Now machine B is under running. So J2 has to wait for 2 minutes. So here J2 has to wait for 2 minutes and it will be load at 8. My dear, J2 has a processing time on machine B is what? 8. So it will be comes out at 16. Now J4 will be load on machine A on which time? J4 will be load on machine time. J4 has a processing time what? 5. J4 has a processing time what? 5. Now J4. Now here J2 is unload. So J4 will load at 6. J4 has a processing time of 5, so it will be out at 11. Now J4 has to wait. J4 has to wait because machine B is busy. Okay, for job 2 up to 16. So J4 will be load at 16. J4 will be load at 16. Now J4 has a processing time on machine B is what? 6. So my dear, 16 plus 6, that is what? 22. J5 will be load on machine A at 11. J5 has a processing time of 9. So it will be out at 20. But still machine B is what? Busy. Machine B is what? Busy. So J5 has to wait. J5 has to wait for 2 minutes. So it will be load at 22. J5 has a processing time of 4 on machine B. So it will be out at 26, my dear. Again, your J1 will be load on machine A at 20. J1 has a processing time of how much? J1 has a processing time of 7. So it will be come at 27. Again, here machine B is free. Here machine B is free at 26. So machine B will wait. Machine B will wait for 1 minute. Machine B will be wait for 1 minute. So J1 will be load at machine B 27. This is a twist. This is a twist, my dear. This is a twist. Are you getting? Now J1 has a processing time of how much on machine B? That is 3. 3. So it will be comes out at 30. Now your J6 will be load on machine A at 27. Now J6 has a processing time of 8. So my dear, 27 plus 8, that is what? 35. Again, machine B is free at 30. But machine B has to wait for 5 minutes. When the J6 will free, then it will load on machine B. So machine B is idle for 5 minutes. So it will be load at 35. Now J6 has a processing time 1 on machine B. So it will be 36. Come out 36. So my dear, make spend time is what? Make spend time is what? Make spend time. Here the make spend time. Here the make spend time. Make spend time is what? Make spend time for the set. Make spend time is 36 minute if the time is in minute. Right. Now ideal time. Now ideal time for machine A. For machine A. Ideal time for machine A. My dear, machine A is running from 0 to 2, 2 to 6, 6 to 11, 11 to 20, 20 to 27, 27 to 35. All the system will shut down at 36. So machine A has to wait for 1 minute. So 1 minute is the ideal time. Now ideal time for machine B. Right, machine B is how much? Machine B is waiting. Machine B started from 2. So it has to wait for 2 minutes plus 2 plus 8, 2 to 8, 8 to 16, 16 to 22, 22 to 26, 26 to 27. Machine B has to wait for 1 minute again. 26 to 27, 27 to 30, 30 to 35. Again machine B has to wait 5 minutes. So 5 plus 1, 6, 6 plus 2, 8. 8 minute. Ideal time on machine B is what? 8 minute. Yes, my dear. All of you are getting this thing. No, Harsh Chaudhary, it's a 8 minute. It's a 8 minute, my dear. It's a 8 minute. Yes or no? All of you are getting the thing. Let me know. All of you are getting the thing. Yes or no? You enjoyed this question? Is this question is informative? That type of question. Actually, I gave little bit little bit lengthy question. Sir, while starting machine 2, that time also machine A will wait for 2 minutes. My dear, machine A is not going to wait. Now see here, machine A is running 0 to 2, 2 to 6, 6 to 11, 11 to 20, 20 to 27, 27 to 35. From where machine Suraj Pandit, from where machine A is waiting, it is in front of you. It is in front of you. It is in front of you, my dear. When you start the stopwatch, when you start the stopwatch from 0, right, machine A is used, but up to 2 minutes machine B is ideal. In front of you, you can see machine A is running from 0 to 35. It will wait for 1 minute when all the system is going to be what? Shut down, because the assumption is that all the machine will start at the same time and all the machine will shut down at the same time. Am I clear? Okay. Okay then. Now let's move. I know 3 job problem will not come in your, it's not in your course, but by this problem I want to clear. Okay, leave this problem because this is a 3 machine problem. 3 machine problem will not in your gate course, but I gave this problem for another purpose, so that you can do more calculation and more calculation. Okay, if you do more calculation, then you become more, you know, you become more perfect. But I will leave this problem. I'm not going to give you this problem. Instead of that, if we get a sufficient time, then we will solve this problem. Meanwhile, I'm going to give another problem. I'm skipping this problem right now. Right? Okay. 3 machine problem is not in your gate course, but this, by doing this problem, you will get lot of confidence. Right now, instead of that, I'm giving some other problems so that we are not going to waste our time. Right? Okay. Yeah, Johnson rule is applicable for planning a job shop for n machine 2 job, 2 machine n job. What is the right answer? N machine n job, 1 machine n job. Tell me. B, 2 machine n jobs. Okay. Now please write down this table. First of all. Please write down this table. My dear. Please write down this table. Have you noted? Please write down this table. Please write down this table. Please write down this table. Noted? Okay. Now, what is the meaning? Basically, there are 2 jobs. This type of question not asked in the gate, and this is a new type of question. 2 jobs on M machine. There are how many machine? M. How many machine? These are what? Machines, my dear. Basically, these are what? Machines. Machine A, machine B, machine C, machine D. Again the same machine. Right? Now, these jobs are arranged. Right? My dear, in this question, I am giving you a graph. According to this data, I am going to give you what? A graph. So the graph is this. Are you getting? According to that data, the graph is this. If the thing is not clear, I will write down. This is 2. Okay. This is 6. This is 10. This is 11. This is 13. This is 16. This is 2. This is 6. This is 11. This is 11. This is 12. What do you have to find out? In the below graph, processing of job 1 is given on machine A. This is basically on this graph. this is job 1. Okay, on this graph basically job 2. So the processing of job 1 is given. Okay, processing of job 1 is given. Let me write down. Job 1, machine A 0 to 2, then machine B 2 to 6, then machine C 5, that is 6 to what, 11. Now machine D, okay, this is machine D. Job is on machine A 0 to 2, job is on machine B 2 to 6, job is on machine C 6 to 11, job at machine D, that is at 11 to 12. In a similar fashion, here job 2 is on machine B from 0 to 2, from 2 to, okay, from 2, 0 to 6, sorry, not 0 to 2. Job basically here, see here, 0 to 6 at machine B, job 2, okay, then 6 to 11 at machine C, then 11 to 13 at machine D, right, at machine D, and from 13 to 16, that machine A. Now you have to find out, what? You have to find out processing time for job 2 on machine A, B, C, D, and processing time. Okay, find the ideal time for job 1 and job 2. Find the ideal time for job 1 and job 2, and total elapsed time for job 1 and job 2. Find out. Find the ideal time of job 1 and job 2 and total elapsed time for job 1 and job 2. Find out. Yes. Find out. Have you seen this type of question before? Yes, find out. Yes. Find out. Suraj Pandit has attempted this question. Very good. I don't know the answer is right or wrong, but you have attempted. That is appreciable. That is appreciated. Okay, I will explain. My dear, I will explain. Try to understand now. When this inclined line come na, basically this inclined line makes an angle 45 degree. Always it makes an angle what? 45 degree from the horizontal. This inclined line show that your job 1 and job 2 both are processing. Understand? Your job 1 and job 2 both are processing. This is an inclined line from 0 to 2. Now this vertical line shows that only job 2 is processing. This again inclined line shows that job 2 and job 1 are what? Processing. This vertical line shows that your job 2 is processing, not job 1. Again this inclined line shows that job 1 and job 2 both are processing. Here this horizontal line shows that only job 1 is processing, not job 2. Okay. Oh, not job 2. Not job 2. You haven't, okay, job 2. So my dear, we have to find the total elapsed time. Total elapsed time, basically it is coming what? Total elapsed time, or yeah, yes, very good, RJK. Here, ideal time for A is what? 5 minutes. Yes, ideal time for, ideal time for job 1. Ideal time for job 1 is what? 5 minutes. Why? Because from 2, try to understand, from 2 to 6, job 1 is ideal. From 2 to 6, job 1 is ideal, right? So here, ideal time, ideal time for what? Job 1 is what? From 2 to 4 it is ideal. 4 plus, from 10 to 11 it is ideal, plus 1. Then job 1 is processing continuously. So ideal time is what? 5 minutes, if time is in minute. Similarly, ideal time of job 2 is what? Job 2 processing 0 to 2, 2 to 6, 6 to 10, 10 to 11, 11 to 16. Okay, this is the ideal time. What is that? This is the ideal time. And ideal time is what? Ideal time is here for 2 minutes. It is not for 2 minutes, 11 to 1. 1 minute is the ideal time. 1 minute is the ideal time. Yes or no? Very good, RJK. Very good, very good, very good. Now, total elapsed time is what? Total elapsed time for any job, total elapsed time, my dear, total elapsed time. Let me write down total elapsed time, total elapsed time for any job equal to what? Processing time plus waiting time. Processing time plus waiting time. If you talk about job 1 elapsed time, then total processing time of job 1, total processing time on job 1 is what? From 0 to 12. See, according to the graph, total processing time is what? 0 to 12 according to this graph. And total waiting time is what? 4. So elapsed time is what? 16 minutes. Similarly, job 2, total processing time is what? Total processing time is what? Sorry. It's a 5, not 4, na? It's a 5. It's a 5. Yes, it's a 5. So it comes 17. Now, job 2 total processing time 0 to 2, 2 to 6, 6 to 11, 6 to 10, 10 to 11, 11 to 13, 13 to 16. And waiting time is what? 2. So here 16. 16 plus 1. Here total waiting time for job. Total waiting time for job 2 is what? 1. So 16 plus 1, that is what? 17 minutes. Is that clear? Can we do by no, my dear? Johnson rule, Suraj Pandit, Johnson rule is for only n jobs on 2 machine. Suraj Pandit, Johnson rule is for only 2 jobs. Okay, Johnson rule is only for 2 machine and n jobs. And here 2 jobs, n machines are there. Right? There is no 2 machine, there are n machines. So how can you apply Johnson rule? How can you apply Johnson rule, Suraj Pandit? You cannot apply Johnson rule. This type of problem will be solved by graphically. This type of problem will be solved graphically, and luckily you get the graph. Luckily you get the graph. If you get the graph in GATE exam, then you can attempt this question. Right? Then you can attempt this question. I hope you understand. Now, linear programming. Yes. Linear programming question. Solve. Solve please. I'm going to give you 2 minutes or 5 minutes. Meanwhile, you try to solve. Then after I will solve. Just make the constant equation only. Just make the constant equation. Just make the constant equation. Yes. Just make the constant equation only. Completed? I don't need the answer, RJK. I just need the constant equation. Although it is good that you are getting the answer, I just need the constant equation. Now I'm going to write the constant equation. I'm changing the slide because the space is not sufficient for me. So I'm going to change this slide, right? Now I have the question in my tab because it's not possible to go in the previous slide and come to this slide. What the question say? Question is saying that a paper mill produces two grade of paper, namely X and Y. Two grade of paper, namely X and Y. Namely X and Y. Very okay. Because of raw material restriction, it cannot be produced more than 400 tons. Okay. Restriction is what? 400 tons of X. You cannot produce more than 400 tons. More than 400 tons, my dear. Here you cannot produce more than 400 tons. 400 tons. Right. More than 400 ton. Okay. More than 400 tons of X. Okay. More than 400 tons of X. And 300 tons of Y. And 300 tons of Y. Okay. 300 tons of Y. In a week. There are 160 production hour. There are 160 production hour. Right. So this is a material and production time is what? 160. 160 production hour in a week. Okay. 160. It requires 0.2 and 0.4 hour to produce a ton of product X and Y. Okay. It requires how much? 0.2 and 0.4 hour a product. So I'm assuming that you are producing X1 of X product and X2, okay, and X2 of Y product. So if you are producing 0.2 and 0.4 hour, 0.2 x1 is the total, 0.4 into x2 is the total of what? Y. Is the total of what? Y. Right? Is the total of what? Y, my dear. Is the total of Y. And total hour is what? Not greater than 160. Is not greater than what? Greater than 160. Right? Is not greater than 160. Now this is a constraint. So what is the constraint basically? He says that if you are going to sell the paper, if you are going to sell X, you are getting 200 rupees profit. You are getting 200 rupees profit per unit, right? And you are getting how much? 500 rupees per unit. It is a very simple question. It is a very simple question. So here the constraint will become what? Here the constraint will become that your x1, if you are assuming that x1 is going to be produced, so x1 is less than equal to what? Less than equal to 400 tons. First of all, why? That is a number of product, I mean whatever you are going to produce, that x2 is less than equal to what? 300 tons. Also 0.2 x1 plus 0.4 x2 is less than equal to what? You cannot take that much more than that hour, right? So the maximization, so this is a constraint equation now. This is a constraint equation. What is the objective equation? What is the objective equation here? Objective equation is z equal to 200 x1 plus 500 x2, right? 500 x2. Clear now? So this is a basic question. Here I gave this question so that you feel motivated. Now in the next question you have to draw the graph. Now in the next question you have to find out the solution. Okay. In the next question you have to find out the solution. Yes, please solve. Please solve. Again I am going to give you 5 to 10 minutes. Please solve. Yes. I think there is little bit misprinting. I think there is little bit misprinting. You solve this question by graphically. Solve this question by graphically, right? Solve this question by graphically, not that. There is little bit misprinting. There is little bit misprinting. Solve this question. Right? Solve this question. Yes. Okay. Shall I solve? Yes. Solve this question. Now, first of all, this is a minimization question. So, I'm going to, shall I change the slide? Because I have to draw the graph. Shall I change the slide? Have you noted this question? Have you noted this question? Shall I change the slide? Okay, I'm going to change the slide. Now you have to minimize this, right? Minimize this. So first of all, we have to draw the graph. So this is what? 5, let's say x1 plus x2 is what? Greater than equal to what? Greater than equal to 10. Okay. We have to convert in intercept form. So it is what? 5x1 plus x2, remove the inequality. So x1 divide by 10 by 5, that is 2. x2 divide by what? 10 equal to 1. Similarly, next inequality, that is x1 plus x2. x1 plus x2 greater than equal to 6. Remove the inequality. x1 by 6, x2 by 6 equal to 1. Similarly, third inequality, x1 plus 4x2 greater than equal to 12. Remove the inequality. x1 plus 4x2 equal to 12. Take an intercept form. x1 by 12, x2 by 3 equal to 1. Am I clear? Am I clear? Okay. Now my dear, draw the graph. Now my dear, draw the graph. Draw the graph. By graphical method, solve. Right. By graphical method, solve. Let's say this is what? x1, and let's say it is what? x2. Clear? Let's say it is what? x2. Let's say it is what? x2. Right. Now you have to draw the graph. You have to draw the graph. So what will be the graph? What will be the graph? Now this is line 1. Let's say this is line 1, this is line 2, and this is line 3. Is any equation is left? 1, 2, 3. Yeah. See. 2, 2, 10, 6 and 12. Okay. So 2, 4, 6, 8, 10 and 12. Similarly here 2, 4, 6, 8, 10 and 12, right? Now at x1, see, at x1 2 and x10, this will be the line. Arey yaar. See, yes, this is a line 1, right? Now line 2, 6 comma 6. Line 2, 12 comma 3. It is 3 and 12. This is line 3. My dear, you can see the intersection will take place at here, and the graph will come this side. Please see. The graph will become this side. This is a graph. 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 So the corner points are what? This is a corner point, right? That is what? The corner points are what? The corner points 0 comma 10 and 12 comma 0, right? 12 comma 0, and if you do the calculation, then you will get 4 comma 2. You will get 4 comma 2. 4 comma 2, right? When you solve equation number 3 and 2, when you solve equation number 2 and 1, then you will get this point. So this corner point is what? 1 comma 5. 1 comma 5, right? So at which point you will get the minima? At which point you will get the minima? I think 1 comma 5. How? My dear, at 1 comma 5 you will get the minimum. What is the objective function? 3x1 2x2. Z equal to what? 3x1 2x2. 2x2. So first of all, the feasible solution. How many feasible solutions are there? Tell me. Tell me how many feasible solutions are there? How many feasible solutions are there? How many feasible solutions are there? Arey Baba, tell me. How many feasible solutions are there? 1, 2, 3, 4. 4 feasible solutions are there. 4 feasible solution are there. And what are they? 0 comma 10 comma 1 comma 5 comma 4 comma 2 and 12 comma 0, and which is optimal? Z equal to 3. 0 into 2 into 10. It will become 20. At this, 3 into 1 plus 2 into 5, that is 13. Z 4 comma 2, 4 3s are 12 plus 4, that is 16. Z at 12, 36. So my dear, this is the minimum. So optimal solution is optimal solution is 1 comma 5 z equal to how much? 13. Z equal to how much? 13. Right? Clear? Yes or no? Are tell me yes or no? Okay then. Thank you for watching this session.